Hello guys, I'm Karthik SP from SPC and today I'm gonna video present network management in computer networks and the subject is computer networks. So let's start. Title: Network management plays a critical role in ensuring that efficient operation and performance of computer networks. Comprehensive overview delays into key components and practices the foundation of effective normal management. Form monitoring and troubleshooting plays a security in optimizing the guide explores the essential elements that contribute in a well-managed and robust computers. Fundamentals of network management, definition and scope, objective, components, understanding the broad scope of network management and its significance in modern IT environments. Objective, examining the primary goals of network management, including reliability, performance, and security. Components, key components such as network devices, protocols, and management systems. Later is the network monitoring and analysis, real-time monitoring, performance metrics, and protocol analysis. Tools and techniques monitoring the network traffic, bandwidth utilization, and device performance in real time. Performance matrices to assess the health and efficiency to the networks. Protocol analysis, network protocols for troubleshooting and optimizations. Fault detection and troubleshooting. Proactive fault detection strategies for identifying and addressing potential issues. Troubleshooting techniques, step-by-step approach to isolate and resolve network problem efficiently. Diagnostic tools, so overview of diagnostic tools such as ping or Trackroot or SNMP for effective troubleshooting. Configuration management, device net configuration, best practices for managing and maintaining the configurations of network devices. Later is the change management, implementing process to track and manage changes in network configuration to prevent disruptions. Security management, threat detection, access control, and security policies. Strategies for identifying and mitigating security threats, including malware, unauthorized access, and data breaches. Access control, implementing measures such as firewalls, intrusion detection systems, and encryption to the securing the network infrastructures. Security policies, sensitive data, and maintain compliance with the industry regulations. Optimization performance. Performance optimization, like bandwidth management, load balancing, quality of service, bandwidth management to enhance overall network performance. Later is load balancing traffic evenly and prevent network congestion. Quality of circuits to meet performance requirements. Scalability and future trends. Scalability consideration, planning for growth of the network infrastructure and implementing scalable solutions. Emerging technology exploration, trends in network management, including software-defined network and network functional visualization, virtualization. Introduction: briefly define network management, importance of effective network management. Introduction: concepts and overview, emphasis on devices and endpoints. Like network devices as routers, switches, hubs, firewalls. Routers are traffic directors forwarding data packets between computer networks. Switches facilitates communication between devices within the same network using a MAC address or efficient data transfer. Hubs, basic network devices that broadcast data to all devices in a network, becoming less common within the rise of switches. Firewalls provide security by monitoring and controlling incoming and outgoing network traffic based on predetermined security rules. Later is the network components. It is a comprehensive overview: file servers, database servers, web servers, application servers. Store and manage files, allowing users to access and share data within the network. Host that database and manage data, supporting various applications and services. Response to requests from web servers, web pages, and content to users. Run specific applications and provide services to the other devices in the network. Later is the endpoints, computers, printers, smartphones and tablets, IoT devices. Like in computers, laptops and PCs are used to interact with no access resources. Printers produce a hard copy of digital documents, often connected to the network for shared printing. Smartphone and tablets, portable devices that connect to the networks for communication, data access, and application use. IoT device, Internet of Things devices such as smartphones, thermostats, and sensor increasingly becoming part of network ecosystem. Briefly explanation of the OSI model highlighting each layer in its role and network management. So role deals with the physical connection between devices, defining network aspects such as cables, connectors, signaling. Network management significance involving managing physical connection, troubleshooting cable issues, and ensuring proper transmission of signals. Later, the data link layer role and its significance. Framing, designing, and error reduction within the data transmitted over the physical layer. Network management significance, local network access, MAC addressing, and resolve issues related to the data link layers. Layers like role and management, uh, to transfer best path for data packets to reach the destination across different networks. Its significance, managing routing tables, addressing schemas, and addressing issues related to the network layer protocol. Later is the transport layer. You have roles and network management significance, reliable data transfer between devices, managing flow control, error correction, and retransmission of lost data. In significance, monitors and optimizes end-to-end communication, addressing issues related to transport layer protocols. Session layer, you have a role as well as network management significance, maintains and terminates communication sessions between applications, managing dialogue coordination. Later, a network management significance, managing sessions and establishing and termination addresses issues related to the session layer protocols. Session layer role translates, encrypts, or recompresses data for efficient transmissions, ensuring compatibility between different data formats. Network management significance involve managing data conversations by encryption by decryption, addressing issues related to the representation layer protocols. Application layer role network significance. Network service directly to the end users interacting with software applications and enabling communications between devices. Managing applications level services, addressing issues related to the network layer protocols. Fault management, configurations, performance management. Definition: fault management is a crucial aspect of network management. It involves detecting, isolating, and resolving issues or abnormalities in a computer network. Later is the configuration management. Definition: handling of network issues to ensure consistency, reliability, and secure approach to devices. Performance management. Performance management focuses on optimizing the efficiency and responsiveness of a computer network. Later in that subpart, monitoring and measurement, capacity planning, turning and optimizing, load balancing, continuous tracking of key performance indicators such as bandwidth utilization, response time, and error rates, capacity planning requirements to accommodate growth and prevent bottlenecks, turning and optimization device to enhance overall performance. Load balancing, distributing network traffic across multiple paths or devices to prevent congestion and optimize resource utilization. Performance management, efficiency and responsiveness of a computer network. Introduction to the monitoring tools, examples of Wireshark or Nagios or SNMP tools. Introduction to the network monitoring tools, real-time monitoring, troubleshooting, performance optimization, and altering and notification. Constantly observes network activity, providing instant insights into traffic patterns, device status, and performance metrics. Troubleshooting, analyzing traffics, identifying bottlenecks, and pinpointing uh, problematic device or configuration. Performance optimizations, areas for improvement enabling administrators to optimize network efficiency, altering and notifications breached or when anomalies occurs, allowing for swift responsiveness to the potential issues. Introduction to the network monitoring tools, Wireshark, Nagios, functionality and its use cases, powerful and widely used packets analyzers that captures and analyze network packets into real time. Use cases troubleshooting network issues, packet level data details. Nagios functionality, open source monitoring, comprehensive view of network infrastructure, application and services. Use cases, monitoring server health, network devices, sending alerts for critical values, facilitating proactive issues resolutions. Later is the introduction to the network monitoring tools. SNMP tools functionality is a protocol used for network management and monitoring device health, collecting and performance metrics, and managing network configurations such as SNMP enabled devices. SolarWinds network performance monitors, functionality use cases, a commercial network monitoring solutions offering real-time visibility into the network performance, fault detection, and comprehensive reports. Use cases monitoring network traffic, analyzing bandwidth utilization, and identifying the resolving network issues. Later is the introduction to the network monitoring tools, PRGT network monitors, functionality comprehensive network monitoring tools that covers a wide range of network devices and systems, providing real-time insights and optimizable alerts. Use cases, device availability and creating custom sensors for specific network parameters. Explanation of SNMP, components, managers, and agents MIBS. Explanation of SNMP. Overview network management protocols is widely used protocol for managing and monitoring network devices and systems. SNMP protocol is a widely used protocol for managing and monitoring network devices and systems. Explanation of SNMP, polling, trap receptions and configurations. Periodically query agents for information using SNMP GET reject request. Trap receptions managers can receive SNMP tracks, which are unsolicited notifications from agents indicating specific events or issues. Configurations SNMP set requests to agents to modify configuration or SNMP enabled devices. Explanation, information provisions, trap generation, response to the request. Agents store and provide information about the device status. Trap generations agents SNMP traps in response to the predefined events or issues. Response to the request, response to the SNMP get request from managers providing the request data and their management information base. Explanation of SNMP, data organization, object identifiers, read and write access. MIBs organize data into tree-like structures where each node responds to specific parameters or variable related. Object identifies identify that serves as its address within the hierarchy. Read and write access written by SNMP managers, providing a level of control other device configurations. Role of network management in firewalls in institutions, detections, and prevention systems. Firewalls, access controls, packet filtering, as well as stateful inspections. Later in the network management implications, configuration management. Proper configuration of firewalls is essential. Later is firewalls. Tools monitoring firewalls logs to identify suspicious activities, analyze traffic patterns, and generate alerts for potentially secure indicators. Role of network management, role in network security, network management implications, insertion detection systems. Later, in security, we have role in network security, network management implications. Bandwidth management, quality of services. So, in bandwidth management, controlling and optimizing utilization of available networks, Key components of bandwidth management. Later in traffic management, regular monitoring network traffic to identify usage patterns, peak times, and potential bottlenecks. Employ network management tools to gain insights into bandwidth and utilization across bandwidth device and its applications. Bandwidth allocation. Prioritizing bandwidth allocations. Implement policies to ensure that mission critical applications receive sufficient bandwidth to operate effectively. Quality of service. Quality of services is a set of techniques to manage and optimize network resources. Key aspects of QoS, quality of services, traffic classification into different categories based on the type of application or services. Assign priority levels to different classes of traffic to ensure appropriate handling. Packet prioritizations, packet over others, ensuring that critical data gets transmitted into minimal delays. Data sensitive and less time traffic to optimize the overall network performance. Congestion management to manage and alleviate congestion in the network to maintain network quality for essential applications. Traffic shaping flow of network traffic to ensure that it conforms into desired traffic policies. Key techniques for traffic shaping and optimization. Later is the buffer management, comprehensive as well as caching. Buffer management optimize buffer sizes to prevent congestion. Implement intelligent buffer management. Comprehensive use comprehensive like algorithms to ensure the size of data packets transmitted. Consumption and speed of data transfers. Caching mechanism to store frequently accessed data reduces the need to retrieve data from the original source. Later is the protocol optimization. Optimize the network protocols for better performance and efficiency. Header comprehensions to reduce the overhead associated with protocol communication. Protocol optimization such as load balancing. The paths or servers to optimize resource utilization, prevent congestions on specific network links and enhance overall performance. Role of congestion management versions and enhanced management for practices conversion management. Definitions involves the systematic management and control of configurations. Documentation or key elements of a system or network. Key roles of network management. Later is ensuring consistency across devices, ensuring consistency in setting software versions and system parameters. Later is facilitating troubleshoot, provides a reference path for troubleshooting, enables quick identification and resolutions of issues. Later is supporting change management for management processes by documenting current configurations, changes over time, propose changes on the overall systems. Support change management enables the identification and the rectification of the authorized or non-compliant compliant changes. Aids regulating requirements and organizing policies by documenting and controlling configurations. Simplifies audits by providing a clear picture of system configurations. Later is the version controls and change management. Definition of change management includes related processes that focus on tracking and controlling modifications. Key aspects of version control and change management. Version control are different versions of files, allowing developers and administrators to revert to previous states. Change management definition role. Management involves the formal process of proposing, reviewing, and approaching. Ensures the change are planned, documented, and reviewed to minimize and disrupting to the system. Best practice for configuration management. Configuration document configuration, implementing version control, optimizing and authorization. Best practices for configuration such as documenting configurations, implementing version control, automation and orchestration. Changes overview or approval and review, audit and monitoring, regular back-end configurations, test and documenting the restoration, Later is the backup and recovery, training and documentation. Provide training to personnel involved into configuration management process. Maintain up-to-date documentation to aid in troubleshooting and knowledge transfer. Security consideration incorporate security best practices, regularly overview and update transfers. Real real world examples like management lessons learned and best practices from industry cases. First one is the Google network infrastructure. Later is the lesson learned and best practices. Next is the common themes and best practices. Automation, scalability, redundancy, monitoring and analytics. Emerging technologies in network management automations. Emerging overview. Configuration management automations. Automated can manage and enforce the consistent configurations. Troubleshoot and remedies can be employed for real-time issues identifications, minimizing downtime. The use of algorithms and computational models to simulate intellectual behaviors. Anomaly detection: AI can detect abnormal patterns in network traffic, signaling potential security threats or performance issues. Later is emerging technologies, predictive analysis, dynamic network optimization. Later is the machine learning in network management, focuses on building models that learn from data and improve over time without explicit performance. Later is machine learning in network management analysis, predictive maintenance, and dynamic resource allocation. Machine learning in network management, efficiency and time saving, automation allowing network administrators to focus on strategic tasks. AI and ML provides quick insights for network performance. Proactive issues resolutions can predict and identify potential issues, enabling proactive measures. Proactive issue resolutions such as adaptability, enhanced security, scalability, data quality, and accuracy. Proactive issues resolution, human oversight as well as integration challenges. Common challenges are like complexity of network infrastructure, security threats, and vulnerability. Later is bandwidth challenges and obstacles. Mm, Next is challenges the rapid pace of technology advancement require continuous learning. Later is can strain resources may lead to delay in implementing latest issues. Next is rapid technology advancement, scalability and growth management, adopt automation and orchestration, implement robust security management, strategies and benefits, strategies including firewalls, encryption and regular security audits, benefits mitigate vulnerabilities and protect fight over a range of cyber threats, implement robust security, strategies benefits on training and skill development, benefits can adapt to a new technology troubleshoots, implementing capacity planning, conduct regular capacity planning assessments, benefits capacity planning to ensure to the network infrastructures. Later is the implement capacity planning, collaborate and share knowledge, regularly review and update policies. So this is the end of this slide. Thank you. Have a nice day.